Hey everyone, welcome back to the channel. So, today we're diving into one of the most essential features of the ESP32, its built in Wi Fi capabilities. I mean, if you've ever wanted to connect your microcontroller to the internet, grab some data from the cloud, or control your devices right from a browser, then this video is definitely for you. Now, the ESP32 comes with built in Wi Fi that supports 802.11 standards, and it works over the 2.4 gigahertz band, which is basically the same Wi Fi band used by your phone and most home routers. All right, now here's where things get interesting. The ESP32 can actually operate in different Wi Fi modes, and today we're going to look at the two main ones that you'll be using most of the time: station mode or STA mode. This is when your ESP32 connects to an existing Wi Fi network. Just like how your phone or laptop connects to your home Wi Fi, in this mode, it acts like a client or a regular device on the network. So now it can access the internet, talk to cloud services, and pull or push data or using things like HTTP, MQTT, or other protocols. Access point mode or AP mode. Okay, so in this mode, the ESP32 actually creates its own Wi Fi hotspot. That means devices like your phone or laptop can connect directly to it. No router or internet needed. Once you're connected, the ESP32 can serve web pages, respond to button clicks, or control devices all locally. So think of station mode when you want internet communication and access point mode when you're doing local control without needing internet. Oh, and one more thing. The ESP32 can even do both at the same time. It supports something called AP plus STA mode, where it connects to the internet and serves a local web page simultaneously. But hey, just to keep things simple for now, we'll focus on using one mode at a time in this video. Alright, so the next big question is, how does it actually communicate over Wi Fi? Well, let's talk about the different Wi Fi communication protocols that the ESP32 can use. So, when the ESP32 is connected to a network, it can actually use a bunch of different protocols to send and receive data. And yeah, each one is kind of suited for different types of IoT applications. Let me give you a quick overview. HTTP, that stands for Hypertext Transfer Protocol. It's basically the same protocol your browser uses to load web pages. Now, with HTTP, the ESP32 can send GET and POST requests to web servers and APIs. It's easy to use, super flexible, and well, supported pretty much everywhere. So, yeah, it's best for things like cloud APIs, basic control systems, or data logging. And just so you know, we'll actually be using HTTP in this video. Now, number two is MQTT, which stands for Message Queuing Telemetry Transport. It's a lightweight protocol that's designed specifically for real-time IoT messaging. It works on what's called a publish-a-subscribe model. Basically, devices publish data to topics and others subscribe to those topics to receive updates. But here's the catch. It does require a broker like Mosquito to manage all the messages. It's perfect for live sensor feeds, automation setups, and smart home projects. We'll go deeper into MQTT in a separate video. So yeah, stay tuned for that. Alright, number 3 on the list is WebSocket. Now this one's pretty cool. It allows full duplex communication, which basically means both sides can send data at the same time. It's more efficient than HTTP when it comes to continuous data streams because you don't need to keep opening and closing connections. So, yeah, it's perfect for things like live dashboards or real time control panels where things need to update instantly. And then we've got another category, TCP and UDP, which are more like low level communication protocols. TCP is reliable and connection oriented, meaning it ensures that data reaches safely and in order. UDP, on the other hand, is kind of like the opposite. It's much faster, connectionless, but yeah, it's less reliable. These protocols are usually used when you need fast and custom data exchange between devices. So think of stuff like audio or video streaming, multiplayer games, or any sort of low latency control systems. So, as you can see, there are quite a few options when it comes to Wi Fi communication protocols. But honestly, for this video, and for many beginner friendly IoT projects, HTTP is like the easiest and most practical way to get started. In this section, we'll learn how to assign the ESP32 to a specific Wi Fi mode. And we'll start with the most common one, station mode. So here is the sketch I've already written. And this code will basically turn your ESP32 into station mode, allowing it to connect to your Wi Fi network just like your phone or laptop. It's super simple. Let me walk you through it line by line so you'll understand exactly what's going on. All right, first up, this line includes the built in Wi Fi library that comes with the ESP32. It gives us access to, well, all the handy functions we need to connect to Wi Fi, check the status, and stuff like that. Then here, we define two constant character strings. One is SSID, which is just the name of your Wi Fi, basically your router's name. And the other is password, which is, the usual Wi Fi password you type in when connecting. So, yeah, just make sure you replace your SSID and your password with your actual Wi Fi details. Okay, moving on. This part here is the setup function. It only runs once when your ESP32 starts up. And the first thing we do inside setup is start the serial monitor at a baud rate of 115,200. That's what lets us print messages and see what's happening while the code runs. Then right here, this is where the magic starts. This line tells the ESP32 to connect to the Wi-Fi using the SSID and password we defined above. Right after that, we print a message to the serial monitor just to let us know that, hey, it's trying to connect. Now this while loop, yeah, this one is pretty important. It keeps checking whether the ESP32 has connected or not. And every half a second it prints a dot, kind of like a loading animation, just to show us it's still trying. Once it finally connects, boom, we print a success message. And right after that, we also print the IP address that the router gave to our ESP32. That IP is actually super important because you'll need it to talk to your ESP32, whether it's from a browser, a mobile app, or anything else. Now, as for the loop function, well, right now it's empty and there's nothing repeating just yet. But don't worry, later on we'll use this space to send requests, read sensors, or like control stuff once the connection is up. Alright, now let's quickly upload the code. Make sure you've selected the correct board and the right port from the Tools menu. Once that's done, hit the Upload button. After it finishes uploading, open the serial monitor and make sure the baud rate is set correctly. If you don't see anything printed, no worries. Just press the reset button on the ESP32. And there you go. Now we can see the output we programmed in the code. Most importantly, we have the IP address right here. This is the address assigned to the ESP32 by your router because we're running it in station mode. Alright, so now let's flip things around a bit. Instead of having the ESP32 connect to a Wi-Fi network, like we did earlier in station mode, we're actually going to make it create its own Wi-Fi network. Kind of like a mini router, right? So yeah, this code here will basically turn your ESP32 into access point mode, or what we often call hotspot mode. Let me walk you through the code line by line just like we did before. Okay, first off, we're including the same Wi-Fi library. Nothing new here. We already used this in station mode and yeah, it works for both modes. Next up, we define our own network. So right here, APSSID is just the name of the Wi-Fi network that's going to show up on your phone or laptop. And AP password is, well, the password you'll need to connect. Oh, Quick heads up here. The password needs to be at least 8 characters long. If it's shorter than that, the ESP32 won't actually start the hotspot. So yeah, just keep that in mind. Alright, now this next line is kind of the most important one. This is where we switch the ESP32 into access point mode. It starts broadcasting the Wi-Fi network using the SSID and password we just set, and boom, it becomes a hotspot. Then here we've got a little message printed to the serial monitor just to let us know that, yup, AP mode is up and running. And finally, we print out the IP address of the ESP32 in access point mode. By default, it's usually something like 192.168.4.1. And that's the address you'll use to open a web page or send requests to the ESP32. So yeah, with just these few lines of code, your ESP32 is now acting as a Wi-Fi hotspot. You can connect to it directly from your phone, laptop, or tablet. No router, no internet required. Super useful for local projects. Alright, now go ahead and quickly upload the code again. Once the upload is done, this is the IP that the ESP32 assigns itself while running in access point mode. And that's it for this section. We've successfully turned our ESP32 into a Wi-Fi hotspot, and now we're ready to start building on top of it. Let's move to the next step. Alright, so far we've seen how to set up the ESP32 in both access point and station modes. Now, as a starting point, we're gonna make our ESP32 act as a web server. It'll, host a simple web page that lets us toggle the onboard LED, turning it on or off directly from our browser locally. This is just the beginning. A small but really powerful step into the world of Wi-Fi and IoT. So yeah. Alright, so this is the code I've already prepared for you. And before we dive into each line, let's just quickly upload it to the ESP32. Once the code finishes uploading, go ahead and open your serial monitor. You'll see an IP address printed there. That's the address assigned to your ESP32 in access point mode. Copy this. Now grab your laptop or mobile phone, open up the Wi-Fi settings and look for a network named ESP32 hotspot. Yeah, that's the one we just created. Enter the password, and once it says connected, you're good to go. Next, open your browser and paste that IP address you saw earlier in the serial monitor. Hit enter. You should now see a beautifully styled web page served directly from your ESP32. Super cool, right? Okay, before we jump into the code itself, I want you to notice something kinda important. Watch this. When I click the on button, the onboard LED lights up. But what's actually happening behind the scenes? If you look at the browser's address bar, you'll notice it changed to something like /LED_on. And that's actually a route we defined in our code. Now here's a little trick. If I open a new tab and just manually type in /LED_off, then hit enter, the LED turns off instantly. No button click needed. So yeah, keep that idea in mind because in just a moment, when we go through the code, you'll totally get how all this fits together. Alright, let's dive into the code now. Alright, so here's the code. Let's go through it line by line and really understand what's going on. We start off by including the same Wi-Fi library as before. Nothing new there. But here's what's new. Web server.h. This little gem gives us a super lightweight HTTP server that runs right on the ESP32. Basically, it lets the ESP32 accept requests from your phone or browser, just like a real website. Pretty neat, huh? Now, this part should look familiar, just like our earlier AP mode sketch. We're setting up the ESP32's network name and password. Then, right here, this line creates a web server that listens on port 80. Now, port 80 is kind of the default port for HTTP. After that, we define GPIO2 as the pin we'll use to control the onboard LED. And we're also setting up a variable called LED state to keep track of whether the LED is on or off. Makes sense, right? Alright, so this is our HTML code. And yeah, it also includes some CSS styling. I'll walk you through the key parts a bit later, but for now, let's just jump straight into the setup function. Inside the setup function, we first configure GPIO2 as an output, and then we make sure the LED starts off by default. So far, so good. Nothing too tricky yet. Next up, this line is what turns your ESP32 into a Wi-Fi hotspot. And just below that, we print the IP address so you know where to connect from your browser. Now, here's the most important concept to understand in this whole sketch. Here, server.on, what does this actually do? Well, think like these lines are mapping a specific URL path to a function in your code. So, for example, when someone types this URL into the browser, this line triggers. So, behind the scenes, it calls a function named handleRoot. Here's what happens. When the user enters this URL in the browser like 192.168.4.1/, the web server checks the path, and because we've registered it using this server.on function, it immediately calls the handleRoot function to serve the HTML page. So it's actually very straightforward, and when the user clicks the turn on button, the browser sends a request to this URL. Then this line is triggered, so it calls the function handle lead on. Similarly, when the user clicks the turn off button, a request goes to this URL, which maps to this in our code. So it calls the function handle LED off. So it's actually very straightforward, whether these URLs are triggered manually by typing it in the browser or automatically by clicking a button on the page. The ESP32 checks which path was requested and runs the matching function we linked using server.on function. Before we move on, let's pause and answer one important question. We've written lines like this in the setup function. But wait, the setup function runs only once, right? So how does this web server keep listening for new requests? Let's break it down. Server.on is not a function that runs continuously. It's like a route registration function. You're basically telling the web server, hey, if someone visits this URL path, run this function. So what actually happens is server.on function simply registers a path like this or like this with a corresponding handler function like these. This registration, it happens just once during setup function. After that, the server already knows. If it gets a request like this, it should call handleRoot function. If it sees request like this, it should call hand LED on function. And so on. But who listens for those requests then? Well, that's handled by this line in the loop function, server.handleClient. Think of this line as the server's receptionist, which always checking, is there a new browser request? Which path is being requested? Okay, which function is linked to that path? Let me call that function and send the response. So even though server.on function is called only once, the actual listening and routing happens in real time inside the loop via server handle client function. Alright, now let's take a look at these functions one by one and understand how everything comes together. So first, this function right here, So this gets triggered when you open the main IP address. Let me show you like this in your browser. Now let's walk into this function step by step. Here, we're making a copy of the HTML template stored in HTML page into a new variable called HTML. This allows us to modify the content, like updating the LED status before sending it out to the browser. Then we're replacing this, yes, inside the HTML with the current value of LED state. So if the LED is on, it becomes on. If it's off, it becomes off. And in the HTML code, you can actually see this here. All right. Finally, this line sends the complete HTML page back to your browser with status code 200, which just means okay, request is successful. So basically, yeah, this function loads the HTML code. All right, let's move on to the second function, the one that runs when someone clicks the on button. So when you press the on button on the web page up, you might wonder, how does the ESP32 know what to do? Let's go back to the HTML part. Right here, this button element, what this line does is, when someone clicks the button, it changes the browser's address to this. That's it, just like clicking a link. This line tells the browser to navigate to this URL. When the button is clicked, I hope everything is starting to make sense now. Then the web server sees this URL and boom, it triggers the handle led on function. I hope that's very simple to follow. Inside this function, we turn the lid on by setting the pin high. We update the led state to true. And finally, we call the handle root function again to reload the HTML page, but now with the LED status updated to on. Alright, and yeah, just like earlier, this line sends the complete HTML content back to the browser. The same thing happens with the off button, so I hope that's easy enough. I hope everything is starting to make sense now. So let me just quickly wrap it up for you. First, we get the ESP32's IP address, right? And then we enter that into the browser. That request hits the root path, which matches this line here. That triggers the handle root function. And what that does is, it prepares the HTML page and sends it right back to the browser. Now, when the user clicks either the on or off button on the web page, the request is sent using these lines in the HTML. Yep, these right here. Basically, those lines tell the browser to visit either the LED on or off URLs, and that, in turn, triggers these route handlers. Each of these functions does three things: turns the LED on or off, updates the LED state, and then reloads the HTML page to reflect the new status. Alright, now just like we did in access point mode, you can try the same project using station mode, where the ESP32 connects to Wi-Fi network instead of creating its own network. Just make sure your ESP32 and the device running the browser are connected to the same Wi-Fi network. Otherwise, it won't work. And here's an important note. Just because your ESP32 is in station mode doesn't mean you can control it from anywhere in the world. For that, you need to go beyond local network communication. And we'll cover that in a dedicated video coming soon. And that's all from this video. I hope you enjoyed the video and learned something useful today. If you did, don't forget to leave a like and make sure to subscribe so you don't miss the next parts, where we'll explore real IoT use cases step by step.